Now see here, this is a spherical surface of radius r, radius of curvature is given to you r, and one object is here. Image of this object is obtained at the point Q, and where C is the center of the curvature, or you can say the center of this spherical surface. So, from the center C, the line which is going here, that is normal to the surface, and point P can be considered as a pole. So, now when the object is here, the two incident rays are taken here, and this they are meeting at the point Q. So, the real image is obtained at the point Q. Now, in the question you are given PO is equal to PQ, it means this and this distance are equal given to us. Refractive index of the spherical surface is here 1.5 and surrounding is air only, so refractive index is 1. Now, we have to calculate PO. It means at what distance object is placed from this sphere so that the image is obtained at Q, and that obviously will be coming in terms of the radius of curvature. So, we know the formula for the rarer to denser medium, because the refraction is taking place from rarer to denser medium, that is minus mu 1 upon u plus mu 2 upon v is equal to mu 2 minus mu 1 upon r. Here we can assume, suppose PO and PQ, let PO is equal to here x, that is object distance, that will be negative. So, we can write minus mu 1, that value is 1. So, minus 1 upon minus x, I have used sign convention, plus 1.5 upon x, v is positive because right to this, is equal to 1.5 minus 1 upon r. Now, we can solve this. So, when we solve this, so we will be getting in this case 1 upon x plus 1.5 can be written 3 by 2. So, we can write 3 by 2 x is equal to 3 by 2 minus 1 upon r. So, we can take 1 upon x common here. So, 1 plus 3 by 2 is equal to, that is 1 upon 2 r on solving this, and now we can write 1 upon x into 5 by 2 is equal to 1 upon 2 r, this 2 will get cancelled. So, we will be getting x is equal to 5 times of the radius of curvature. So, here x or the object distance is coming here 5 times of the radius of curvature.